Hello students, we have done the mathematical derivations of all equations of motion for constant acceleration and problems based on them. We will revise all these things later on, but today we are going to start to study the variation of these physical quantities like acceleration, velocity, displacement, distance traveled with time. That is, these physical quantities are changing with time or are not changing. After that, we will learn how to plot a graph of variation of these physical quantities with time. Once we will learn all these things, we will also learn to analyze these graphs and get information from there. This graph preparation or graph plotting you have to do with full concentration and patience. Let us start. Uniform motion. All of you know the definition of uniform motion. Uniform speed and uniform velocity also. Uniform speed, uniform velocity both will come under the case of uniform motion. So we will start from uniform speed. First we will take the case of body at rest. How we will plot it? Let us see. Here we will take two coordinate axes. This is the y-axis and this is the x-axis. And this will be the initial point. And we have to show that body is at rest, means the distance of the body from a reference point is not changing with time. Here two physical quantities are here. One, the distance of the body from the reference point, and another time. We will plot time on x-axis and distance traveled on y-axis. And for this, let us assume the situation. This is the distance, we represent it by x, and this is the time. Distance is measured in meter and time is in second. Now see, the position of the body is 50 meter when time is 0. And when time is 1 second, again the position is 50 meter. 2 and 3 seconds, the position of the body is not changing. This is the situation. How we will plot here? Let us see. When the time is 0, the position is 50 meter. Suppose this is 1, 2, 3, 4, 5. The body is here. Now for 1 second. 1 second here, the position of the body is 50. 2 seconds, the position of the body is again 50. 3 seconds, the position of the body is 50, and so on. We will get finally a straight line parallel to time axis. We will write here time in second and d or x for the displacement in meter. This is the graph for the body at rest. First case, body at rest. Now what we will conclude from here? We will conclude when the body is at rest, The graph plotted between distance traveled and time will be a straight line parallel to time axis. Let us write it. When body is at rest, the graph plotted between distance traveled and time when a body is at rest, the graph plotted between distance traveled and time is a straight line parallel to time axis. Okay. Body is again 50. 3 seconds, the position of the body is 50, and so on. We will get finally a straight line parallel to time axis. We will write here time in second and d or x for the displacement in meter. This is the graph for the body at rest. First case, body at rest. Now what we will conclude from here? We will conclude when the body is at rest, the graph plotted between distance traveled and time will be a straight line parallel to time axis. Let us write it. When body is at rest, the graph plotted between distance traveled and time when a body is at rest, the graph plotted between distance traveled and time is a straight line parallel to time axis. Now this is the second case, uniform speed. For this case, let us see a situation. Here again we will take this type of information for you, and from here we will plot the graph. Distance travel is represented here by x, and this is in meter. Time is by t, and this is in second. The time is 0, 1, 2, 3, 4, 5 and so on, and from here the distance travel is 0, 10, 20, 30 and 40, 50 so on. In this case we will plot a graph, and again we will take the y-axis and this is the x-axis. This point is the origin. We will start from here. On the x-axis we will plot time in second. On y-axis we will plot distance travel in meter. For distance travel we will assume 0, 10, 20, 30, 40, 50 and so on. And this side 1, 2, 3, 4, 5, 6, 7 and so on. And in background there is a graph. Remember, you have to plot on graph. In this way also you can, but it will be better there to plot on graph. Now let us plot. For 0 second, the displacement is also 0. Here, for 1 second, the distance travel is 10. Means here 1 second and this is the displacement 10. 2 and then 20. 1, 2, then 10, 20. This point will come here. Now 3. 1, 2, 3, then 30. 3 and 30. Then 10, 20, 30. 4 seconds, then 40. In this way, we will get a straight line. But this straight line is not parallel. It is inclined to time axis. You may say this is inclined to distance travel axis also, but it will be convenient to say it is inclined to time axis. Now what we conclude here? When a body is moving with uniform speed, the graph plotted between distance travelled and time will be a straight line inclined to time axis. The second thing is there, from the slope of this line, suppose this is O and we put here A, this line, we can find out the speed of the body. How you will get this information from the graph, we will see just after writing the point. First point is the graph plotted between distance travelled and time. Distance travelled and time will be a straight line, inclined to time axis. Inclined to time axis. In your notebook, this point should be written below this graph. Okay. A second point is the slope of the graph. The slope of the graph plotted between distance travel and time. Distance travelled and time gives the speed. This slope is new for you. Okay. In this graph, OA is a slope. This line is a slope of this graph. And how we will get speed from here? Let us see. This is the initial point. 0 will come here. And on this axis, the distance travelled is plotted. And this point is 10 meter. This point is 20, 30, 40 and 50 so on. And this side we have plotted time on x-axis. 1 second, 2 second, 3 second, 4 second and so on. For the slope of the graph, we have to draw a perpendicular at any point. Means at the time of distance travel 30 meter. And when we will draw this 30 meter in this way, and we will match this side, this will match to 3 seconds. In this case, the slope of the graph will be slope of the graph or line of this graph OA, slope of this line OA will be equal to BC by OC. Suppose this is a triangle OBC. In this triangle, the slope of the graph is equal to perpendicular by base. Now you see how this is equal to the speed of the body. In this case, uniform speed, the acceleration is 0. Then the formula of distance traveled will be only ut. Half at square will become 0. So only we will leave is ut, and u is equal to s by t. Here now compare these two. This is the distance traveled and BC is also the distance traveled. Here the time in denominator, then here is also OC. OC is time. Therefore, this will give the speed of the body. In this case, in this graph, the slope of the graph will give us speed of the body. And how we will find out the slope? We will find out in this way. This implies 30 by 3 means what? The speed is 10 meter per second. Similarly, other point also you can take. Just you take the distance travel 40 meter. Then the time, corresponding time will be 4 seconds. And again 40 by 4 you will get the 10 meter per second. So in the case of uniform speed, you will find out slope from any point, you will get the same amount, 10 meter per second. Now why we tell the slope will give the speed? Due to this resemblance. This resemble to this. This is the question based on the slope of the graph. Here the information is here for car A and the information for car B is here. On the basis of this information, graph A is plotted here, and on the basis of this information, graph B is plotted here. Because this is for car B and this is for car A. So we have written here car A and for car B. Now we will find out the slope of these graph or this line OA and OB, and on the basis of that we will decide which one is moving faster or which one is going slower. So let us first find out the slope of the graph with help of this graph. For car A, let us take any one situation. This point we will take. This is at 2 seconds. The distance travelled by car A is 40 meter. And the slope of the graph will give what? Slope of the graph will be equal to perpendicular by base for this triangle. This is 40 and this is 2. And this implies that 20 meter per second. The speed of car A is 20 meter per second. You can take another point also. From here, at when car A is at 20 meter, the time taken is 1 second, and from here also the speed will come 20 by 1, that is 20 meter per second. So the speed of the car from this graph is 20 meter per second. Let us see for the car B, and any one point again we will take. Let us choose this 3 second. At 3 second, the distance travelled by car B is 30. Then the slope of the graph will be slope of graph for car B will be equal to, again for this triangle O, this point, suppose B or C or D or A, anything. For this triangle, this is the perpendicular, this point, this distance is perpendicular, that is 30, and this is the 3 second. Therefore, the speed is equal to 10 meter per second. Now let us see which one is moving faster. Obviously, car A is moving faster than the car B. Or you may say car B is moving slower than the car A. Now, without calculating the slope, from this graph, we can say directly which one is going faster and which one is going slower. The slope which is inclined, more inclined towards the time, is moving slower than the slope which is less inclined to the time. I want to repeat, the slope which is inclined more towards the time is going slower than the slope which is less inclined.